So our next topic name is justifications. So our next topic name is justification. So how the assigned data is stored into the variables internally. Okay, justification means how the so we are assigning the data for numeric, we are assigning 0 to 9 numbers, right? So in alphabetic, we are assigning the data. So the data is A to Z capitals. Okay, respond.
Yes, ma'am.
So we are assigning the data to COBOL variables. So that variables, how they are assigning internally. Okay, how the assigned data will be stored into the variables internally. Okay,
Yes, ma'am.
so there are two ways in this justifications. One is right justification. Second one is left. Okay, we have two justification, right justification and left justification. So if you are using value class during the variable declaration, only we are allocating the data. Okay, if you are using value class while declaring the variable only, we are allocating the data. So it follows the compatibility rules we have already seen. Okay,
Yes.
so can you see the screen?
Yes, ma'am.
Yes, ma'am.
So if you are using value class, so how the numeric data will be stored? So if you are using value class in numeric, the data will be stored in form of right justification. Okay.
Okay.
We are declaring the group variable 01. WSC is my variable name, picture class. I'm using numeric data type, allocating 3 bytes of memory, and my value is also numeric 1, 2, 3. Okay. So how this 1, 2, 3 is stored internally into this variable. Okay, that is the justification. So we have 3 bytes of memory, 3 boxes. So my data is 1, 2, 3. So firstly, the 1 will be stored in the first box. In the second step, 1 move to right side and 2 will be stored and 1 move to right side like this and 2 move to second position and 3 will be stored. Okay, this is called right justification. Understand?
Understood, ma'am.
So the next example is I'm allocating group variable WSA picture class numeric and my picture class length is 4 bytes of memory, but I'm allocating the value for 2 bytes of memory only. Okay, here I allocated memory for the 4 bytes, but my data is only 2 bytes of memory. So for in the first position 5 will be stored and 5 more to right side and 0 will be stored. Okay, so the remaining spaces will be filled with 0 in the numeric. Okay, got it?
Yes, ma'am.
Then your remaining spaces will be filled with the 0. If I am displaying WSA in display, we can see 0050. Why? Because means I'm allocating the 4 bytes of memory and my data is only 2 bytes of memory. So in value class, in numeric, it follows the right justification. So the remaining spaces are filled with 0. So that's why you can see in display spool area 0050 is my output. Okay.
Okay.
So the next example is my picture class WSA variable name picture class numeric data type 3 bytes of memory, but I am allocating 5 bytes of memory. Here my memory is 3 bytes, but I am allocating the data is 5 bytes of memory. Okay. It follows the compatibility rules. So that's why we are getting maxi 8. Compilation error maxi 8. Got it?
Okay. Yes.
Yes, ma'am.
So the next data type is alphabetic. Alphabetic follows the left justification. Okay, I'm declaring 01 group WSA picture class alphabetic 3 bytes of memory value, assigning the value A, B, C. So if you are writing in your notes, we used to write from the right to left. So you can directly send the value from like this. It follows the left justification. Okay, got it. Hello.
Yes, fine.
Yeah. So we are using WSA picture class 5 bytes of memory, but I am allocating 3 bytes of memory only. So value class alphabetic follows the left justification. So TB2 is stored and the remaining spaces, the remaining memory is filled with spaces. Okay. If I see display WSA in my spool area with numeric data type of 3 bytes of data, you can see only DB2. These two are filled with spaces. Okay.
Okay.
So the next scenario is I'm allocating alphabetic data type. Here 3 bytes of memory, but my data is 5 bytes of memory. So value class follows compatibility rules and rule number 2 is file compilation error with maxi 8. Okay. Understand?
Yes, ma'am.
So the next data type is alphanumeric. Alphanumeric also follows the left justification like alphabetic. Similarly, my data type is alphanumeric 3 bytes of memory. I am allocating 3 bytes of value. So it follows the left justification and stored like this db2. Okay. So here I am allocating 5 bytes of memory and 5 bytes of data also. Similarly, it will also
Okay.
store like this only. So here I am allocating 7 bytes of memory, but my data is only 3 bytes of memory. So here the 3 bytes of memory fill with the JCL, my data, and the remaining 4 bytes of memory fill with spaces.
Yes.
Okay.
Yes, ma'am.
This alphanumeric data type is 3 bytes and I am allocating 7 bytes of memory. Rule number 2 fails. You will face compilation error with maxi 8. Okay.
Yeah.
So this is about the value class.
Money.
Yeah, tell me.
Actually, in the alphabetic column, like we have given the byte A5. Okay, 5 bytes we have given.
Yes.
Okay, we are taking DB2.
Yes.
Means we can take DB is a alphabetic character, but we can take two in that.
Okay.
It means
Oh,
DB means it got alphanumeric, na?
yes. Sorry. I write here in the wrong way.
No, I have one more doubt. Whatever we have given in the double single quotes, it will convert it as a string, no money.
Yes. Here,
It's also right. If we keep it in single quote, then it will convert it into alphabetic
Yes,
also.
yes, Baba.
what? Tell me one more time.
So whatever we have given in the single quotes, it will convert it as a string now. Even if I giving the numeric also.
No. The representation of the alphabetic will be within the quotes only. In the-
Okay,
No,
can't
money.
we write a numeric value in quotes that will act
No.
as a character?
In
Alphabetic.
alphanumeric, it will accept. In
Okay.
alphabetic, you can write it only alphabetics only.
Okay.
So here my data is IBM, not DB2. Okay.
Okay.
So here also B is there. M. Okay. Not DB2. Okay. So nice.
Yes.
Okay. Any doubts in this value class? Justification? Any doubts in this value class justifications?
No money.
No.
So, so next one is accept statement justification. Okay. So previously we have seen value class justifications. So now we'll see the accept statement justification. Okay. Accept statement, my numeric data follows. Left justification. Okay. Here I am allocating group variable WSA picture class 9 of 5 bytes of memory. Accept WSA by using in-stream data concept in execution JSL by using in-stream data concept. I am passing the data to my COBOL variable. Okay. If I am displaying WSA, I can see 1, 2. Okay. Accept statement numeric follows the left justification. 1, 2 will be stored and remaining spaces are filled with spaces.
Yes.
Okay.
Okay.
So in the next scenario is numeric data type. I am allocating 6 bytes of memory by using accept statement and execution JSL. By using in-stream data concept sysdata star, I am allocating the data to my COBOL variable. So my data will be stored in 6-digit formats. 1, 2, 3, 4, 5, 6. Okay, 6 bytes of memory is allocated, but I am giving here 10 bytes of memory. Okay, here I allocated 6 bytes of memory, right? Hello.
Yes, money.
Yeah, I am allocating 6
Yes.
bytes of memory, but in sysdata star I am giving 10 bytes of memory. Okay, it will store from the starting MAIN FR 6 bytes is completed and remaining AMES will be truncated, means deleted. Okay,
Okay.
truncated means deleted.
Okay.
Okay,
Yes.
so the next data type is alphabetic, and alphabetic also follows the left justification. So here I am allocating the 11 bytes of memory for the alphabetic except statement. In execution JCL, I'm passing the data. So my data is 1, 2, 3, 4, 5, 6, 9, 0 numeric data. Why? Because except statement never follow the compatibility rules. Okay. So I'm passing data is numeric and my data type is alphabetic. So it will store 10 digits and last 11th digit will be stored with space. So display WSA in spool area I can see 1, 2, 3, 4, 5, 6, 7, 8, 9, 0. Okay.
Okay.
Next data type is alphabetic. In alphabetic, except statements also follows the left justification. So I'm allocating 10 bytes of memory except statement by using system register. I'm passing the data to COBOL variable. I'm displaying the variable COBOL 1, 2. Okay. 7
Yes,
bytes
sir.
of memory is used in COBOL 1, 2 and remaining 3 spaces are filled with spaces.
Yes.
If you compare value class and accept statement, you can see in value class, so in value class numeric only we are following the right justification. In remaining all the cases, value class, alphabetic, value class, alphanumeric, and accept statement, numeric, alphabetic, and alphanumeric, we are following the left justification only. Okay? In
Yes, one.
numeric only, we are following the right justification. And remaining all the cases, we can see left justification only. Okay?
Yes, sir.
So in
In
value class, accept state.
in accept statements
Hmm.
means for the spaces zeros are not filled, right?
Yes, if you are
In
following the
numeric.
left justification, the extra memory is filled with the space. But in value class, numeric, the spaces are filled with zeros. Okay?
Yes.
Okay.
Only this value class numeric only follows the right justification and
Right.
remaining
Yes, sir.
spaces are filled with zeros. In remaining all the cases, the remaining spaces are filled with spaces and follows the left justification and accept statement never follow the compatibility rules. So that's why we are in system register we can give numeric data in the alphabetic also. Okay, and here you can give numeric data for alphanumeric. This is also acceptable. Okay.
Okay.
So here my data type is what? Numeric. I am passing the data is also numeric. My data type is numeric. I am passing my data is alphabetic. Okay. And your picture class length is less than to the data means the remaining characters are will be truncated. Okay.
Yeah.
So what is the memory is allocated by the picture class? That much of data is only stored and remaining data will be truncated, means deleted. Okay. Got it?
Yes,
Yes.
ma'am.
Yeah, okay. So if you have any doubts, you can ask me.